in your practical course is determination of refractive index of a glass by the phenomena of total internal reflection. Now this is a glass given, alright. You have to determine the refractive index of the material of this glass by studying the phenomena of total internal reflection. Now here the basic concept is that when ray of light or light will pass from denser medium to the rarer medium at one particular angle of incidence, that angle is called as a critical angle, the refracted ray will be not observed. The ray of light will pass parallel to the surface of the glass, so that angle of incidence is called as a critical angle, and beyond that angle the ray of light will get totally internally reflected into the same medium. So that is the concept of this experiment. Now here the experimental setup for this experiment is, you are having this glass slab, here this board is there on which the angle of incidence, angle of refraction you can measure, or angle of transmission you can measure. So on this board it is there. Then the source of light is there. So this is the source of the light. From that light will incident on the glass. The incident angle you can change, and corresponding angle of refraction we can note down. And for critical angle, the ray of light will pass parallel to the surface of the denser medium, and that angle you have to note down. Now you know the theoretically, you are going from first medium having refractive index n1, then angle of incidence will be sin theta c. You are going into the another medium, the refractive index will be n2, and the angle of refraction will be sine of 90 degree, which is the threshold condition for total internal reflection. Then refractive index you have to determine. So formula is mu equals to 1 upon sine of theta c. Now you know the theta c, you find out the sine theta c, take the reciprocal of that will give you the angle of refraction. Now here, as you will change the angle of incidence, what will be the corresponding angle of refraction that you can note down here. These are the angle of incidence. Critical angle, once you get, corresponding angle of refraction will be 90 degree, and once you get by the formula refractive index of the glass by total internal reflection, you have to write it. Basic concept of the physics. Total internal reflection, the angle of incidence, when it will be critical angle, what happens, that angle of refraction will be 90 degree. This you people have learned in the lower classes, but we will observe it here as experimentally, and will determine the refractive index of the glass. Now let us see the experiment how the angle will change. So put it here, the glass slab. Now here you can see the ray of light should pass. So this is the incident beam of light, ray of light that will pass it through. Now you can change the angle of incidence. Why you here 10 degree, 20 degree, 30, 40 it is marked. As you will change the angle of incidence, corresponding refracted ray of light will be visible. So here I will switch off the light, and then how the angle of incidence changes and how the refracted light will be produced, that you will be able to see. And for one angle of incidence, for critical angle, the ray of light will pass parallel to this surface, and beyond that it will get totally internally reflected. So now at present lights are on. So when I will switch off the light, you will be able to see that. That will be the experimental demonstration of this experiment. And then by using the formula mu equals to 1 upon sine theta c, you will be able to determine the refractive index of the material of the glass. Now let us see, you can see this arrangement you will have to make. So you can see this is the glass slab. So initially the beam of light you can see, I will put this slab here, alright. Now here the light is incident normally on it, and it is straightway passing through the slab. Now as I will change the angle of incidence, so here you can see the angle of incidence I am changing. It has been made 10 degree. What is the corresponding angle of refraction, you can note it down. Then I will make it 20 degree. Then you can change the angle of incidence here. Here this is the refracted ray, corresponding angle incidence angle you note down, corresponding refraction angle you note down. Then you go to the next angle. So you can see this is the refracted ray of light. Now as you will change it, now here you can see this is the refracted ray of light. Now here it is refracted. Now here for this angle, now it is near about coming parallel to the surface. Here it is parallel to the surface. Now here you can see, here it is. Now just go beyond this. Here it is parallel to the surface. Now you will be observing the total internal reflection. So here you can see this is the total internally reflected ray of light. So for this is the incident ray, this is the total internally reflected ray of light. If I decrease this angle of incidence, then you can see this is the refracted ray. Now this is going parallel to the surface, and then now it is internally reflected. So like this way, the angle for which for critical angle you can find out, the ray will be going parallel to the surface. Theta c you find out, 1 upon sin theta c will give you the refractive index of the material of the glass.